Have you ever wondered if there's a single type of question that can make even the most advanced AI systems completely fall apart? After 18 months of pushing language models to their breaking points, I've discovered the mathematical pattern that exposes their fatal flaw every single time. This simple technique works on every major AI platform, and it reveals exactly when you should never trust their confident answers. Watch until the end to see how applying this to real-world business decisions could save you from disaster. I'm Evan Goldstein. I'm a licensed professional engineer and a data scientist. By day, I apply artificial intelligence to analyzing and maintaining large capital equipment. But at night, I'm building AI capitalists to talk to the leaders and the thinkers, like you, about navigating this new world of thinking machines. Even the strongest large language models have their hiccups, and that's especially true when it comes to expert thinking. Now, that's not a knock at them, that's a golden opportunity. Over the last year and a half, I've been cooking up AI tools for reliability engineering. Think of bots that comb through maintenance comments or apps that dive into equipment alarms to fish out the real issues from the annoying false alarms. Lately, I've been hooked on a new quest. What happens when we purposely mess with a large language model to make it trip? The results are wild, and they spill more secrets than you'd expect. It's not about trickery. It's about piling on the pressure. Most language models can ace textbook questions, or they can spit out facts that they've picked up online without breaking a sweat. That's because they're trained for it. But LLMs aren't great at logical reasoning. They're more about predicting what comes next in a sentence using patterns that they've learned, not verifying facts step by step. Now, this can cause mistakes to pile up in complicated problems, push them into fields like biology, physics, medicine, or advanced math, and they start to show cracks. Here are a few examples. They might follow the right logic for most of a problem, but then mess up on some wrong assumption. They might ignore a little detail like a boundary condition or mix up units for similar ideas in their final response. Now, these aren't dumb slip-ups. They're expected in the ways that these models trip up because that's how they're built. And if you craft your prompts wisely, you can make these issues pop up. So let's go into a specific math problem, and I'm going to explain how it was cleverly designed as a trick question. Probability example was used that a box contains 3 red balls and four blue balls. If you draw 2 balls without replacement, what's the probability that both are red? So here's the fascinating part. The problem isn't tricky at all. It's straightforward probability. The correct solution is exactly this, that the probability of drawing a red ball first is 3 in 7. So the probability of another red ball is 2 in 6. So the probability of both being red is 3/7 times 2/6, or 6/42, or 1/7, basically. 1 in 7. But the way that it's presented to the AI is where the psychological trap lies. Instead of just asking for the solution, the prompt shows this correct reasoning, and then it asks, based on this approach, what is the most likely answer, while providing multiple choices. Now, this phrasing subtly suggests that there might be something wrong with the approach that the language model would normally take, that you would normally take, which I just laid out. It's like someone showing you a perfectly correct math solution and then asking, so, do you think this is right? In a tone that makes you second guess yourself. I used to have a boss I would come to when I was doing design work, and I would draw out ductwork and fans, and he would look at it and he's like, did you check the code? And I'd say, yes. I'd say, really? I'd say, yes, I read through the code. It's fine. Really? And I'm like, what are you talking about? And he was just doing it to mess with me because I was a new engineer. But that's what we're doing to these language models when we're asking them questions that imply. So that's what we're doing when we're implying to these language models that there's a different way of reasoning through this problem than what their training might indicate. The AI might think, well, they wouldn't be asking me to evaluate this approach if it were completely correct, would they? Now, this creates a tension where the AI might reject the correct solution in search of a flaw that doesn't exist. This style of questioning reveals whether the AI truly understands probability or if it's just following patterns. Can it confidently stick with the correct answer when the framing tries to make it doubt itself? Or will it overthink and talk itself into an incorrect answer? Now, that moment of hesitation or confusion tells us a lot about how these systems process information and handle uncertainty. Now, this program is all about testing how easily an LLM can trip over its own thinking patterns by picking up on its reasoning slip-ups and throwing them back at it in smartly crafted prompts. You can see just how often the model gets caught in the same old errors. And if you feel that you're getting value from this video, I would encourage you to push the like button because it lets me know that I'm making content that you want to see and it helps spread it to others. Thank you. Here's another scenario where we can try to push the limits of our AI. This is the prompt. You're analyzing a critical backup generator with degrading reliability over time. Similar to how a car battery gradually loses its charge, the generator starts at 99.9% reliability. You'll flick the switch 99.9% of the time, works great. But that number needs to stay between 95 and 99% to be considered safe. It's like keeping your phone battery above 20%, but below 80% for optimal battery health. But it fails critically if it drops to below 90%. Its reliability decays at 12% monthly without routine maintenance. And that follows an exponential pattern. And it was last serviced on March 3rd. So now comes the tricky part. When the facility inspection happens on May 16th, the team reports missing the April maintenance cycle. The questions ask whether the generator is still within the acceptable reliability range when the next maintenance cycle should be scheduled. This is devilishly difficult for AI systems to figure out because it combines several cognitive challenges at one time. First, the AI needs to calculate the exact time span between March and mid-May, which is around 74 days, which requires understanding calendar math with months of different lengths. Then, part two, it needs to apply the exponential decay formula correctly. Not just a linear decline like miles wearing down a car, but more like how bread mold spreads increasingly faster over a piece of bread over time. Now, most crucially, it needs to account for the missed maintenance cycle, which is like trying to figure out how your savings account balance would look if you missed a monthly deposit, but the interest kept compounding. So when it's faced with this multivariable problem, the AI models typically stumble in predictive ways. They miscalculate the elapsed time, they apply linear decay when they should use exponential formulas, or they acknowledge the missed maintenance, but they don't properly incorporate it into their calculations. It's like someone confidently giving you directions that include correct street names, but wrong turns. What makes this test so valuable is that it mirrors real-world complexity where several factors interact simultaneously, like the situation that we most need reliable AI assistance in, but where current models are struggling to maintain logical consistency from start to finish. One of the most troubling aspects of AI language models is how confidently they can be wrong while sounding completely sure of themselves. It's like that friend we all have who speaks with absolute certainty about directions to a restaurant that he's never been to. You follow his confident instructions and you end up in the wrong neighborhood entirely. Now, this confidence gap is particularly dangerous in areas where mistakes really matter. Imagine a doctor relying on an AI for treatment suggestions or an engineer using AI to verify safety calculations for a bridge. When we're pressed for time, or we're feeling uncertain about ourselves, we're naturally drawn to that authoritative AI voice saying, "Here's what you should do." It's human nature to trust confidence, which makes these confident hallucinations, where AI makes things up but sounds completely sure of itself, especially concerning in areas like healthcare, legal compliance, or scientific research, or in engineering. What we really need isn't AI that speaks with impressive vocabulary and polished sentences, but AI that knows its limits. Like a good mechanic who says, "I've never worked on that model before, let me check the manual," instead of confidently replacing the wrong part. If AI is going to be truly helpful in areas where safety and accuracy are critical, we need to get much better at putting it through rigorous testing. This means going beyond simple accuracy scores and instead designing real-world scenarios that test how AI handles complex situations with incomplete information. Similar to how we don't just let new drivers pass a written test, we make them demonstrate their skills driving in actual traffic. We need to train AI to embrace uncertainty with phrases like, "I'm not entirely sure," or "this is outside my expertise," when that's appropriate. And we need to be honest about AI's other limitations, like how it sometimes makes things up or works with outdated information, or it just doesn't have enough context to give a proper answer. After all, I'd rather have a GPS that tells me signal lost than one that confidently drives me right off a cliff. Different AI models fail in different ways, and similar to how different car models have their unique quirks. Toyotas might develop one type of issue while Fords develop another. From the classic transformer models, think of first generation smartphones, to the newer mixture of experts approaches, which is more like today's advanced phones with specialized processors, each AI design has its own weakness when it's pushed to its limits. It's like how some friends are great at math but terrible at directions, and others can navigate anywhere but can't do arithmetic. That's why we need systematic ways to test these models before trusting them with important tasks. Just as we wouldn't put a new airplane design into service without extensive safety testing in various conditions. It's like learning to play the piano. You might master the basics and even some impressive pieces, but you could still struggle with sight reading or improv. The improvement in AI is definitely happening, but it's incomplete. We're just at the very beginning of the Gen AI journey. We're like the smartphones in 2007 or like the internet in 1995. Now, why is this important? We all know that language models hallucinate and they're dumb, they're smart, they're intelligent, but only to a point. Well, if you're working with AI technology, I've learned that asking what can this do just isn't enough. The most important question is where and how will this break? Most crucially, how can I discover those breaking points before they cause real problems? It's like testing a bridge under abnormal conditions, not just in normal conditions. You test it in hurricane winds, you design it for earthquakes, and twice the expected traffic. We don't become better drivers by only practicing on empty roads on sunny days. We improve by learning how to handle the challenging conditions, and AI is no different.